Deep beneath the surface of Geneva, something truly extraordinary, yet potentially dangerous, sits. The Large Hadron Collider, LHC. This colossal machine is a marvel of modern science, capable of peering into the tiniest parts of the universe, and has already helped scientists make groundbreaking discoveries like the Higgs boson, often referred to as the God particle. The Higgs boson was a significant find, filling in gaps in our understanding of how the universe operates. But, as exciting as this achievement is, there are concerns about what we might be unlocking in the pursuit of knowledge. As physicist Brian Cox once suggested, something hidden has been found at CERN, and it has sparked curiosity and fear. Could we be venturing down a dangerous road, probing realms we don't fully understand? Before we delve into these worries, let's first look at what the LHC is and how it works. CERN runs the LHC, a massive 17-mile ring of magnets that forms the largest and most powerful particle accelerator in existence. Its scale and capabilities are awe-inspiring, allowing scientists to recreate the energy conditions similar to those present when the universe began by smashing protons together at incredibly high speeds. The LHC mimics the conditions of the Big Bang, enabling researchers to probe the fundamental building blocks of the cosmos. With temperatures soaring millions of times hotter than the sun and cooling systems keeping things colder than space, the LHC achieves feats that once seemed impossible. The LHC's intricate setup is a testament to human ingenuity. Inside, there are over 1,200 magnets guiding the protons and another 392 focused magnets directing them to their collision points. To hit particles with the precision needed, think of trying to collide two needles 6 miles apart, requires an astonishing level of accuracy and technology. The accelerator is buried underground, shielding the world from harmful radiation, and kept at a chilling temperature of 460 degrees Celsius. As the particles crash into each other, detectors like ATLAS, CMS, ALICE, and LHCb record the data, capturing crucial insights into the nature of matter and the universe itself. The Higgs boson, for instance, could help us understand how mass is distributed across the universe, offering a glimpse into the very structure of everything around us. However, while the LHC is an incredible tool for unraveling the mysteries of the universe, its immense power raises some unsettling questions. As we peer deeper into the unknown, we must ask, are we prepared for what we might find? Could we be inadvertently unlocking forces we don't fully comprehend? Some have raised the concern that, in our attempts to mimic the Big Bang, we might be opening a Pandora's box of unforeseen consequences. Recent comments by Brian Cox have intensified these worries. He explained that, by recreating the extreme conditions of the early universe, the LHC could lead to unexpected, even dangerous, results. The collider, after all, doesn't just explore the Higgs boson and other known particles. It also delves into dark matter, which accounts for a large portion of the universe's unseen mass. But dark matter, as the name suggests, remains elusive. Its properties and composition are still a mystery. The LHC could be our best chance at unraveling its secrets, but this could also bring unforeseen risks. The collider's extreme conditions, akin to those that existed at the very birth of the universe, come with dangers that must not be ignored. Scientists have even speculated that the collider could inadvertently create tiny black holes, spurred by the potential of quantum physics to warp space and time. This concept has attracted the attention of prominent scientists like Stephen Hawking, who warned that high-energy experiments at the LHC could lead to vacuum decay, a catastrophic event that could unravel space and time itself, with consequences potentially as dire as the destruction of Earth. Sir Martin Rees, a cosmologist, echoed these concerns, suggesting that such instability in the vacuum could have disastrous effects. CERN, of course, insists that any black holes created by the LHC would be short-lived and harmless. Still, the notion that we might accidentally create something as dangerous as a black hole, even a minuscule one, has made the scientific community more cautious. Despite these warnings, it's essential to acknowledge that the risks, while real, are incredibly low. CERN has established safety protocols to mitigate these dangers. However, no amount of preparation can completely eliminate the inherent uncertainty of pushing the boundaries of scientific exploration. As we delve deeper into the fabric of reality, we must weigh the potential risks against the knowledge we hope to gain. The LHC is a tool of immense power, one that is as much about the human drive for discovery as it is about scientific progress. It demonstrates our relentless desire to understand the cosmos, but it also highlights the responsibility that comes with such power. Beyond the existential risks, the LHC's effects reach into various realms of knowledge and technology. With over 10,000 scientists, engineers, and technicians working on this colossal project, the collaboration spans the globe. The data generated by the LHC is so vast that it has revolutionized computing, requiring new methods of data storage and analysis. But the implications of the LHC go far beyond particle physics. The research conducted at CERN has far-reaching effects on fields such as medicine, material science, and environmental studies. For example, understanding the Higgs boson better could lead to the development of entirely new materials or technologies. Similarly, the LHC's work on dark matter may one day uncover hidden aspects of the universe, fundamentally changing our understanding of space-time and physics itself. At the same time, the LHC's work with concepts like supersymmetry and extra dimensions could radically reshape our comprehension of the fundamental forces of nature. Supersymmetry, Toller's research also has profound implications for the future of computing, especially in the realm of quantum computing. By revealing how particles interact at a quantum level, the LHC is paving the way for technologies that could one day revolutionize how we process information. Yet, as we stand on the brink of these monumental discoveries, we must also confront the ethical questions that arise. While the pursuit of knowledge is thrilling, it comes with the responsibility to ensure that this newfound understanding is used wisely. The potential applications of LHC research are vast, but so are the risks. From developing advanced weapons to creating technologies we cannot control, the possibilities are both exhilarating and terrifying. This raises an important ethical dilemma. How do we ensure that these discoveries are used for the benefit of humanity and not to cause harm? Global cooperation and transparency are key to addressing this challenge, ensuring that the knowledge gained through the LHC is shared and utilized responsibly. The LHC also raises significant concerns about the environmental impact of such powerful technology. With its enormous energy requirements, the LHC places a considerable strain on resources and ecosystems. While CERN has made efforts to reduce its carbon footprint by relying on renewable energy and improving efficiency, the environmental consequences of such large-scale scientific endeavors cannot be ignored. This underscores the need for sustainable practices in science, particularly as we continue to explore the frontiers of knowledge. As the LHC continues to unravel the mysteries of the universe, it serves as a reminder of both the power and potential dangers that come with humanity's drive for knowledge. It's not just about the breakthroughs in physics or understanding dark matter. It's about exploring the very building blocks of existence and what happens when we try to manipulate them. With each experiment, each collision, scientists push the limits of our understanding. Yet we must also be mindful of the profound responsibilities that come with wielding such power. The LHC is a testament to human curiosity, a desire to answer questions that have perplexed us for millennia. But the pursuit of answers in this realm of extreme conditions and unknowns forces us to consider not only the scientific implications, but also the moral and ethical ones. What if, in our quest for knowledge, we uncover things we are not ready to handle? What if the answers to questions we've asked for centuries come with consequences that we can't predict? One of the most unsettling possibilities is the impact the LHC might have on our understanding of space and time. The idea of vacuum decay that has been discussed by some of the leading minds in physics isn't just an abstract concept, it's a real possibility, albeit a highly unlikely one. But if something went wrong and the vacuum state of the universe changed, it could lead to a chain reaction that could destabilize everything we know. It's a chilling thought, yet it's one that has to be considered when dealing with such powerful experiments. The LHC could alter the fabric of the universe itself, and while CERN has safeguards in place, it's hard to predict what we might learn and what those discoveries might mean for the very fabric of reality. What makes this situation even more complex is the global nature of the LHC project. The machine itself is an international endeavor, with scientists, engineers, and technicians from more than 100 countries working together to answer questions that could have massive implications. The LHC operates as a microcosm of global cooperation, but it also brings to light questions about accountability and transparency. The stakes are high, and the knowledge that comes from this machine isn't limited to one nation or group. It belongs to the entire world, and existential challenges. We must ask ourselves, how far are we willing to go in our search for answers? And at what cost? The risks may be low, but the potential rewards are immense. As we venture further into the unknown, we must balance our curiosity with wisdom, our drive for progress with the responsibility that comes with such power. The future of science and of humanity will depend on how we manage this balance. The Large Hadron Collider, for all its brilliance and promise, is not just a tool for scientific discovery. It is a reminder of the delicate balance between knowledge and power. It calls on us to proceed carefully, thoughtfully, and responsibly as we explore the uncharted territories of the universe. As we continue this journey of discovery, the LHC becomes not just a tool of scientific advancement, but a symbol of the complexities and ethical dilemmas we face in our quest for greater understanding. The knowledge it provides has the potential to reshape our view of the universe, but it also forces us to ask critical questions about the consequences of such knowledge. How do we responsibly harness this power? How do we ensure that the discoveries made at the LHC are used for the betterment of all and not for destructive or selfish purposes? There is a fundamental tension between the excitement of discovery and the uncertainty of the unknown. Each new breakthrough brings with it new possibilities, but also new risks. With each proton collision at the LHC, we uncover more about the fundamental forces of nature, the origins of the universe, and the nature of dark matter. Yet we are also confronted with the possibility that the very act of investigating these mysteries could lead to unforeseen consequences: the creation of miniature black holes, the destabilization of the vacuum of space, or the development of technologies that could be misused. All of these are potential outcomes that we cannot fully predict or control. The reality is that the LHC and the field of particle physics as a whole are at the frontier of human knowledge. We are peering into the deepest recesses of the universe, asking questions that have never been asked before, and attempting to understand forces and phenomena that were once thought to be beyond human comprehension. In this pursuit, we are venturing into a realm where the boundaries between science, philosophy, and ethics blur. It's no longer just about understanding the mechanics of the universe. It's about grappling with the responsibility that comes with this newfound knowledge. What makes this journey even more challenging is that science often moves faster than society can keep up. The advancements made at CERN could lead to groundbreaking discoveries in fields like quantum computing, material science, and medicine. However, they also carry the potential for unintended consequences, both in terms of the physical risks associated with the experiments themselves and the ethical implications of how the knowledge is applied. How do we ensure that the discoveries made at the LHC are used in ways that benefit humanity as a whole, rather than being exploited for profit, power, or destruction? And this brings us to the question of governance and regulation. The LHC is an international endeavor, and its potential impact spans the globe. As such, it requires a level of global cooperation and accountability that has never been seen before. How do we ensure that countries with different values, priorities, and concerns work together to manage the risks and rewards of such powerful technology? The LHC is not just a scientific project, it's a global one, and its implications reach far beyond the walls of CERN. Decisions made here could affect the future of our planet, our understanding of reality, and the course of human history itself. The importance of transparency, ethical oversight, and global cooperation cannot be overstated. We must engage in open and honest discussions about the potential risks and benefits of the LHC's experiments. The scientific community, policymakers, and the public must work together to ensure that the pursuit of knowledge is balanced with the duty to protect our world and future generations. As we push the boundaries of what is possible, we must also take responsibility for the potential consequences, both the known and the unknown, and then there's the environmental impact. The LHC's immense energy requirements and its role in the consumption of global resources highlight the need for sustainability in science. The pursuit of knowledge should not come at the expense of our planet's well-being. The scientific community must strive to minimize its ecological footprint and ensure that future generations inherit a world that can sustain their own discoveries and innovations. This balancing act between progress and preservation is a delicate one, but it is essential if we are to move forward responsibly. As we look to the future, the LHC stands as a testament to humanity's unyielding desire to explore, understand, and innovate. But with this incredible tool comes an equally incredible responsibility. The search for the unknown is both thrilling and dangerous. It is a journey that requires humility, caution, and foresight. As we unlock the secrets of the universe, we must remain vigilant, ever mindful of the risks and the profound ethical questions that accompany such powerful knowledge. In the end, the Large Hadron Collider is more than just a scientific instrument. It is a reflection of our collective aspirations and anxieties. It is a reminder that while knowledge has the power to transform our world, it also carries with it the potential to reshape our very existence in ways we may not yet fully understand. As we continue to push forward in our search for answers, we must do so with a deep sense of responsibility, ensuring that the discoveries we make serve to benefit all of humanity, not just the few. Thank you.